and my subscribers here. Welcome to my channel. Today's topic is looking at solubility product constant calculation. In part 1 of this calculation, we calculated KSP. So this one, we are giving KSP and we are asked to find the molar solubility. Okay, so I'm going to write equilibrium equation for this reaction. So I have magnesium. I want to have here 1 mole of this. Of course, produce 1 mole of this. Produce 2 moles of this. We don't actually know the molar concentration of this. We don't know it. So we can select it be what? S. So let the molar solubility of magnesium fluoride be S. So it means that the number of moles of magnesium fluoride that dissolve in 1 dm cube or 1 liter solution is S. If it's S, the one of magnesium ion in the solution will be what? Also be X mole. And this one also be what? 2X. That's what it means. Solubility product expression. So KSP is Mg2 plus times fluoride ion raised to power 2. So what's the KSP? It's given in the question 6.4 times 10 raised to power minus 9. So I'm going to substitute this value, this concentration, into this. So you have magnesium is S, fluoride ion is 2S, raised to power 2 is equals to 6.4 times 10 raised to power minus 9. So when you have S times, let me express this in first. So S, so 2 squared is 4. X squared is what? This is 4S squared. S times 4S squared. You'll be having 4 raised to power, 4x raised to power 3. So 4x raised to power 3 is equals to 6.4 times 10 raised to power minus 9. If I divide 6.4 by 4, 6.4 times 10 raised to power minus 9 divided by 4. So I'll be having, that is 6.4 times 10 raised to power minus 9 divided by 4. So the value will be 1.6 times 10 raised to power minus 9. So what will be the value of S? So cube root of S will give us 1.17 times 10 raised to power minus 3. So what should be the unit? This is concentration, mole per dm cube. So since S is 1 mole, so it means that the molar solubility of X, which is magnesium fluoride, is 1.1 times 10 raised to power minus 3. So since X is 1.17 times 10 raised to power minus 3, the molar solubility of magnesium fluoride is 1.7 times 10 raised to power minus 3 mole per dm cube. Alright, so let's look at question number 2. Calculate the molar solubility of strontium tetraoxide 6 in water, given that the solubility constant is 1.0 times 10 raised to power minus 31. Okay, solution. So I'm going to write the equilibrium expression of strontium sulfate. So this equation, this equilibrium expression for strontium sulfate. So what it means that 1 mole of this produce 3 moles of strontium ion, also produce 2 moles of sulfate ion, phosphate ion. So the molar concentration of strontium sulfate, we don't know it. We select it be X. And this one will be 3S, and this will be 2S. So that's this S is in mole per dm cube. So we're going to write the solubility constant product equation for this. So strontium ion raised to the power of the coefficient, which is 3, times phosphate ion raised to the power of the coefficient is what? 2. So we're going to substitute what is the KSP value? It's 1.0 times 10 raised to the power minus 31. So we're going to be expressing, we're going to substitute this concentration into this. Strontium is 3s raised to power 3. Phosphate is 2s raised to power 2. Plus 1.0 times 10 raised to power minus 31. So 3s raised to power, when you express this, you'll be having 3 square is 9. S3 times 2 square is 4 times S square is equals to 1.0 times 10 raised to power minus 31. Okay, look at this. 9 times 4 is 36. So you have S raised to power 3 times S raised to power 2. It will be S raised to power 5. Add the powers together. So 1.0 times 10 raised to power minus 31. S raised to power 5 will be 1.0 times 10 raised to power minus 31 divided by 36. So we're having 2.78 times 10 raised to power minus 33. So what should be the value of S? So 2.78 times 10 raised to power minus 33 root 5. When you punch it in the calculator, you'll be having X will be 3.08 times 10 raised to power minus 7. So the unit is what? Mole per dm cube. So the molar solubility of strontium phosphate is 3.08 times 10 raised to power minus 7. The solubility dot constant of silver cyanide is 1.2 times 10 raised to power minus 16 at 25 degrees Celsius. So calculate the amount in grams of silver cyanide that will be present in 25 liters of water at 25 degrees Celsius. So solution, let's write the equilibrium expression of silver. So this is the equilibrium expression of silver cyanide. So 1 mole of this produce 1 mole of this of silver ion, produce 1 mole of cyanide ion. Okay. So this question, we don't actually know the amount, we don't actually know the molar concentration. So we're going to assume, we'll call it S. Let it be S mole per dm cube. So this one is S. Of course, all of them is the same mole ratio. Alright, so the product constant for this equation is Ag ion times cyanide ion. And what's the KSP? It's 1.2 times 10 raised to power minus 16. So I'm going to substitute this value into this equation. So S times S is equal to 1.2 times 10 raised to power minus 16. So of course S squared is equal to 1.2 times 10 raised to power minus 16. What should be the value of S? 8 mole per dm cube. So remember, we are asked to find the amount in grams, that's mass, amount in grams that will be present in 25 liters. So we're going to find the molar mass of AgCN. So molar mass So silver is 108, carbon is 12, nitrogen is 14. So when we sum this together, we're having